Hello everyone. So for statistics term 2, I will show maths problem until this point 8. After 8, I'll show it later. But for until 7.2, we just have to remember one single equation. The equation is sigma by root n. Sorry, 2 actually. One is this sigma by root n and another one is this p into p bar into 1 minus p bar by n whole root over. So these two formula, if you remember, you don't have to remember anything. Okay. Now, first kind of question where we have to calculate margin of error or confidence interval, those kind of thing with a confidence level of alpha. Okay. Now, if alpha is given, we can calculate z alpha by 2. We can calculate t alpha by 2 if n is also given. So I'll come to this later. Okay. So the only formula you have to remember is sigma by root n. So if population standard deviation is given, that means sigma is given, and sample size you also know. So you can calculate sigma by root n. This is called standard error. And if it is population, we will calculate z alpha by 2. Okay. If alpha is, let's say, 5, we can calculate z alpha by 2. Okay. And multiplying all both of this, we can calculate margin of error. And to calculate confidence interval, it will be just x bar plus minus MOE. Now, if in case of population, we have sample standard deviation and not population, then we will use S. Okay, S is the standard deviation of the sample, and we can again calculate the same thing. And for t distribution, we will use the same thing, alpha by 2, but comma degree of freedom we have to provide, which is just basically sample size minus 1, and same formula. Okay, and if sometimes maybe they will ask to calculate what should be the n, and MOE is given. So what you have to do is just substitute the values and calculate n. Okay. After that, the same thing for hypothesis testing. What you have to do is at the top you should always subtract the sample average minus population, whatever the hypothesized value you have. Like let's say your sample mean is 5 and you are testing the hypothesis that it should be greater than 6. So 6 is the mu 0 hypothesized value and 5 is what is happening in your sample. So difference between that by that sigma by root n, which I said previously. And if it is a population, we will use z, and if it is a sample, we will use t. Okay. Yeah, let's say. And after that you can calculate the z value and t value. And for the population proportion, it will be always z. There is no t in this case, and it will be p bar into 1 minus p bar by n. P bar is whatever we got from the sample. Okay, so this is the basic formula, and you don't need to remember this formula. It is substituted. So substitute the values here. If n is, you need to calculate n and then calculate n. Then hypothesis testing for it is always again same. It's p bar minus p0. P0. P bar is your standard, your samples p bar, and p0 is your hypothesized value. So how to identify which problem is what? If population standard deviation is given, then the formula will be sigma. This one sigma by root n. If sample standard deviation is like population standard deviation is not given, then sample standard deviation. And if proportion is given, like probability 30%, 40%, that is coming under population proportion, this formula. Okay, done with hypothesis testing. Now in these three scenarios, we will also have three kind of hypothesis testing: right-tailed, left-tailed, and two-tailed. So if it is a right tail test, you know how to what you know how we can understand what is right and left and to tell, right? If let's say our alternative hypothesis is what we want to prove is mu 0 greater than 5, then it's a right tailed. If we want to, let's say it's number of chocolate kid eats in a week, and we want to test test the hypothesis that it should be greater than 5, so then it's a right tailed. And if our hypothesis is it's less than 5, then it's a left tailed test. And if our hypothesis is not equals to 5, then it is a two-tailed test. Now remember, these are the alternative hypotheses. These are the alternative hypothesis values. Actual null hypothesis will be the opposite of this. So for the first one, it will be mu 0 less than equals to 5. For the second one, it will be mu 0 greater than equals to 5. And for the third one, it will be mu 0 equals to 5. So after calculating this right tail, left tail, and two-tailed, we can calculate the z statistics before and right. Now to calculate the p-value from the z, let's say z value we found out 2. Okay, so for the right tail test, it will be 1 minus norm dot dist this z value. If it is left tailed, it will be norm dot s dot dist, and if it is two tailed, it will be 2 into 1 minus norm dot dist. Okay, now any combination can come into the picture. So if you didn't understand, I'll just solve some problem. I'll try to solve some problems with this. So it's the wave assign, first wave assign. Okay, let's do this problem. Okay, it's mean standard deviation, not necessary. Okay, this one, margin of error we have to calculate, right? So data we have collected that amount spent by 64 customers for launch at a major Houston restaurant. These details are contained in the file Houston. Based upon past studies, the population standard deviation. So population standard deviation is given. So sigma is given. So at 99 confidence, what is the margin of error in dollar? So if sigma is given, what did I say? We have to use sigma by root n, right? This one. So we have sigma, let's unknown, and this is for proportion. Okay, it got paused. Sorry about that. I don't know where it got paused. Uh, yeah, so here in the problem, sigma is given. So we have to, if sigma is given, we will use sigma by root n formula, right? So sigma is 7 is given, and n is number of customer, which is given also 64. And we have to calculate x bar. X bar is average from your sample. So if we select the whole table, and average of the whole thing, it will be coming to 2152. So x bar is given 21.52. Okay, now at 99% confidence, what is the MOE? So if you check, the formula for MOE is this one, z alpha by 2 into sigma by root n. So sigma is given, n is given. We can calculate sigma by root n, which is standard error. Sigma root n equals to sigma by to the power 0.5 is 0.875. And now alpha values, alpha confidence interval is 0.1, 0.01, because 99% means alpha is 0.01 or 1%. That means alpha by 2 is this by 2. Now then z alpha by 2, z alpha by 2 will be norm dot s dot dist. Now then MOE will be z alpha by 2 into standard error, 0.439. I guess z alpha by 2 we have to do. Let me check once. Okay. Z alpha by 2 we have to calculate. So if we draw the picture, it is here 21.52. So we need an interval of 99%. This value is 0.05, this value is 0.05. So z alpha by 2 will be higher, right? So it will be, I guess, 1 minus. Okay. So I think I am doing something wrong. Okay, sorry. Alpha by 2. What is alpha by 2? Alpha by 2 is a percentage, which is a probability proportion. So for proportion, we need to do inverse. Okay, this one is a thing which people can get confused. So I also got confused, which is if when to use norm.s.dist and when to use norm.s.inv. So if the value inside it is a probability, you have to use inverse. And if in the inside value is a z value, then we have to use dist. So now alpha by 2 is not a z value, this is a probability function. So we have to use inv. And here we have to provide the probability, right? So alpha by 2 is 0.005, so the probability will be 1 minus. So this will be the answer, 2.2538. Yeah. Develop a 99% confidence interval estimate. So it will be just the plus, upper, lower. Upper will be this plus x bar and lower will be minus, sorry, this minus mi. So this will be the answer. So using the same thing, you can do any of the problems here. Here also is the same. If you see 3027 sigma is given, the sigma is 3027. Okay, sample size is 55. X bar is 19,100. Standard error will be sigma by root n. This confidence, what is the 95% confidence interval estimate of the mean cost to repair smoke and fire damage that results from home fire caused by careless use of tobacco? 95% means alpha is 0.5, 0.05. So now you see we have already 18300 to 19899.98, which is 99,900. Okay, so the same thing you can do anywhere. Now I'll show a different kind of where we don't have population standard deviation. The maximum possibility rating is 10. Suppose a simple random sample. Okay, here no samples population standard deviation is given, right? So the average is and the standard deviation is, so the same thing. If population is unknown, we will do, but the only thing we will change is z alpha by 2. Here we will have t alpha by 2. Okay, now we have 6.38 as the mean. Sigma as 2.12. So it's not sigma here, it is called S value, standard deviation you can say, and it is 2.12. Now n is number of, which is 50. Standard error alpha is 95%, so 0.05. Now t alpha by 2, how we will calculate is t dot inverse, because it's a probability. Probability will be 1 minus this, comma, degree of freedom will be n minus 1. Now you'll have upper and lower, that is I think required 5.75 to 6.98. Okay, it's a bit different. Why is it? It's only 5.78, right? And then what transfer? Hmm, I'll check once. I think one thing that can happen is standard deviation is this, and we can take 2.1. Just if we change it to the exact value, I don't know what will happen. Okay, that was the reason. You have to take the perfect values. 5.05. Okay. Now you can do the same thing for the others also. And now I will show some of the p bar thing, right? So in p bar we have values like probability value and then n value, and then the whole formula of standard deviation, and then these things will be same alpha by 2. Okay, and MOE will be and into here we will calculate the whole thing like standard error, which is whole root over p into r minus p by n. So for the problem, this research center has solved of 845. The sample survey showed 93% of respondents said the internet has been a good thing for them personally. So the probability is 0.93 and number is 845. Standard, okay, STD we don't have here, right? Standard error we have. Standard error is P into minus P by N, the whole thing to the power 0.5. Standard error we have alpha, we have MOE equals to K5 and upper will be K, not K9, K8, sorry, K9 plus K2, and here it will be K2. So 0.94, 0.912. So yeah, this one. The same you can use everywhere. This is done. Now I'll do for the hypothesis things, all kind of like left tail, right tail, and two tailed. Yes. So for this one, where sigma is given 9 minutes, 35 surveys. Similarly, now it's first sigma is given, which is 9, 35, n x bar we have to calculate from the chart. It's to average of the whole thing 17. So average is 17. Standard error is then calculated alpha. Now, sorry about that. Now we have to do a hypothesis testing where mu naught, so it's a right tail test, right? Because we are saying that So you have to understand why it is right tail. So for the question, if you read it out, it's that base charge to a client on the assumption that telephone service can be completed in a mean time of 13 minutes. So it said that it will be completed in between in like before 13 minutes. If a longer mean survey time is necessary, like if it is greater than 13, then a premium rate is charged. So the null hypothesis is it should be less than 13. So this is the null hypothesis, the above line. So the alternative will be greater than 13. Now here we have to compute the value of the test statistic. So sigma is given. So what is the value of test statistics? For calculating test statistics, so this from this to this, it's basically you can say for confidence interval and margin of those kind of thing. And test statistic is for hypothesis. So test statistics is given by, so for test statistics we have to calculate the z value, right? Which is, so we have to first write down the hypothesized value, which is given here as 13. Now the z value is, so is x bar minus hypothesized value by the standard error. This is the z statistics. Now it's right hand. So right, left, two tailed. Now if you remember, what I have done is for right I have told you. So this is a z value, right? So we have to do norm dot s dot dist because it's not a probability. If it was a probability like alpha or those kind of thing, we would have done inverse. This value, comma, true. So this is the right hand tail, right hand. Left hand will be norm dot s dot dist, and two tail would be 2 into this. So it is right tailed. So the p-value is 0.004277. Now compute the value of test statistics. Test statistics value is 2.629, which is 2.63. What is the p-value? P-value is, it is right tailed, 0.43. Now this is another one of that same kind of a question. So here, so this is a two tail, right? Because it is said that it should be deferred. It is not lower or higher like that. So it's a two tail, and there is no, you know, population standard deviation. So you have to calculate the standard deviation for the sample. So if we use sample, what we do? We use t values, right? So we can say these are related to those. Now here hypothesized value, it will be kind of a same. Hypothesized value. Now here in case of z stat, it will be t stat, and t stat value will be this one, right? And here also it will be not norm dot s dot, it will be t dot test, and degree of freedom will be n minus 1, and it will be cumulative. Okay, now in this scenario, 10,182 is the hypothesized value. Sample we have to calculate, right? Now average should be this much and STD should be this. So standard deviation is this. N is given as 50. Okay, X bar is this. Standard error then this much and hypothesized value is this much. T stat is this value. Then right tailed is 1 minus T dot dist. This will be T dot dist. And two tailed will be, we cannot have probability more than one, right? So two tailed in this scenarios will be 2 into I guess for T distribution. Okay, okay, let me check once. So yeah, T distribution is correct. P value is 0.0339, which should be okay. Two-tailed. One thing I missed is two-tailed should be 2 into the lower of these values, whatever is the lowest value. So in this case, this one is the lower value. It should be into 2. Now why it is coming is, if you want to understand, this is like a normal distribution, and let's say here is the critical value, T star value. Now right hand is this much, right tail probability, and left tail is this much. So to calculate the T, we have to take mirror. We have to do mirror, right? So if we mirror this part here and add the both, we will get two tailed. But in scenarios of where the values are like this, we cannot mirror the whole thing. We can mirror this part. So then we had to mirror this part and then calculate. Okay, so similarly, let's do it for a p value. Probability, yeah. Here the hypothesis value is 0.12, and I think this will come under, if you calculate the total number of PS by the total number, it will be 0.13. So here we'll have a hypothesized value 0.12. Probability actual sample is 0.13. N is 100. So hypothesis is 0.12. Now using alpha as 0.05, conduct your hypothesis test. So for here we use z statistic always, right? Z stat, and that is equals to this minus, sorry, sample minus actual. Okay, here I think one thing is different. While calculating the standard error, we have to do take the P0 hypothesized value. Just I'll do it here. So I'll just copy this thing. Okay, there is no point of copying. Or there is. In case of K2, we will write K12, K12. So now the stat value is 0.307 or 31. If it was K5, how much was it? See, if it was K5, it was around 29. It's L5. So yeah, another thing to remember, if it is at about this confidence interval and everything, the standard error is calculated based on the sample probability, and if it is hypothesis testing, the standard error is calculated based on the hypothesized value. After calculating this stat, it's pretty much similar. So this is 3791. Okay. So this is done. Hypothesis testing is done. All three combinations I have shown.